Welcome to Chapter 3. As you'll see, 3.1 is a very short section and not too bad. So we're talking about exponential functions. We've dealt with exponents and polynomials, but now the difference is that the exponent is the variable. So we don't have things like x squared. We have things like f of x equals 2 to the x. So these are some formulas that we're going to try to make some sense out of this first one for sure, and the second one involving interest. There's a whole lot of good financial problems in this chapter. So if you're ever one of these, it's like, wow, when will I ever use this in my life? There's a lot of things outside of just straight mathematics, just regular life that can be very valuable to understand. So with that, let's just go ahead and get started. We'll come back to those formulas for compound interest. And we start out here simply with just evaluating exponential functions on our calculator. So boy, they're really letting us into this pretty easily here. Pretty easy start. So for number 6, we just want to find the value to 3 decimal places, as you can see. And so we've got 1.2 raised to the, of course, just a review, that is the caret key to get an exponent, raised to the. And 1/3, you can enter it as a fraction, but you can just enter it as 1 divided by 3. And we get approximately 1.063. And no real difference for number 8 here. As I said, pretty simple section in a large part. So 8.6 raised to the negative, don't hit minus here, raised to the negative, and then we get 3 times negative second square root of 2, and that is it. And we just get 9,220.217. So now we're dealing with a whole new branch of parent functions when it comes to graphs. And until we get used to these, you could probably T-chart a lot of these things just in your head, but I'm going to build T-charts for 10 through 16. I'm going to expect you to do the same for 9 through 15, and then I'll give you some more freedom down the road. So on an exponential function, I'm typically interested in building around what makes the exponent 0. So I'm going to build around 0. Now, if this was an x plus 5 as an exponent, I'd build around -5. You're going to see that soon. So I'm going to put in 0. 10 to the 0th is 1. I'm going to put in 1. 10 to the 1st is 10. I'll go to 2, put in 2. 10 to the 2nd is 100, so I'm definitely going to have to scale my y-axis here to make much sense out of this. I'm going to put in -1, go the opposite way. There's what I'm claiming is like our MyVox to build around 0. Put in -1 and I get 10 to the negative 1st, or 1/10. Put in -2, 10 to the negative 2nd, or 1 on 2 to the 2nd, 1 on 100. It doesn't take us long to realize the bigger the negative value I put in, the closer and closer and closer we get to 0, but we don't make it to 0. So we're to graph that. I don't know, I think I'm just going to count by 2s. We're not going to get to the 100. 2, 4, 6, 8, 10, 12, 14. So this will be 14 up here, and I'll just count by 1s on my x-axis. So 0 gives me 1, counting by 2, so we're right there. 1 gets me up to 10. -1, by the time I'm at -1, I'm virtually at 0 already, just not quite there. And then we get sucked into this asymptote really quickly. So we're just coming right along here, and then this thing just explodes upwards. It gets real steep real fast. So there's our graph. We've got our T-chart, which I am going to require that from you on this page, and identify asymptotes and intercepts. Well, we have an intercept at 0, 1. That's y-intercept. We have no x-intercept, and because we never get down to 0, and we have a horizontal asymptote of y equals 0. Okay. So x, y, again my MyVox on this problem is 0 because 0 makes the exponent 0. 10 to the 0th is 1. When I put in 1, I get 10 to the negative first, 1/10. When I put in 2, I get 10 to the negative second, 1 on 100. When I put in negative 1, I get 10 to the first. And when I put in negative 2, I get 10 to the second, which isn't going to fit on our graph, although we could count by 10s, I suppose, or by 15s, 20s, whatever, and make it fit. But I'm going to again call this 14 up here. Put in 0, get out 1. That is an intercept. Put in 1, get out 1/10, virtually 0. Put in 2, get out 1/100th, even closer to 0. Whoops, I pulled away a little bit there. Put in negative 1, get out 10. Put in negative 2, get out 100, which is really taken off. So our y-intercept, or excuse me, our y-intercept is 0, 1, but our horizontal asymptote, again, is y equals 0, and we have no x-intercept. Could we have an x-intercept? Sure, if the graph is shifted down. But if there is no downward shift or upward shift, the horizontal asymptote is always y equals 0. Okay, 3/2. X, y. Put in 0. 3/2 to the 0th is 1. Put in 1, get out 3/2. Put in 2, get out 3/2 squared, or 9/4. Okay, now there's room to put in some bigger values here. Put in 3, get out 3 to the 3rd, 27 on 2 to the 3rd, 8. That's just a little bit more than 3. 27 divided by 8. I'm going to go to 4. We get 81 on 2 to the 4th, 16. And now we're up above 5. So this one's growing pretty slowly compared to the previous one. Put in negative 1, and we're quickly going to get a feel for what happens here. That flips the fraction 2/3. Put in negative 2, and we get 4/9. And again, we're still getting closer and closer to 0. I'm going to count by ones here. 1, 2, 3, 4, 5. Of course, it's 7 up here. Put in 0, get out 1. 0, 1 is an intercept. Put in 1, get out 3/2. Put in 2, get out 9/4. 4/4, 8/4, 9/4. Can barely tell it's even growing. Put in 3, get out 27/8. There's 8, 16, 24, 27. It almost looks like a straight line. Put in 4, get out over 5. Put in 4, we're over 5. It actually is curving up a little bit. And we could go ahead and probably put in 5, and that might fit on the graph as well, or something in that line. Now when I put in negative 1, I'm at 2/3. Put in negative 2, I'm just under 1/2. And again, we're getting sucked into 0 this way. So we have a horizontal asymptote again of y equals 0 and no x-axis. Or excuse me, no x-intercepts. And 3/2 to the negative x, we're going to see a lot of the same values. X, y, put in 0, get out 1. 0, 1 is an intercept. Put in 1, that's 3/2 to the negative first, flips it 2/3. Put in 2, flips it 2/3, but squared 4/9 under 1/2. And pretty clear what's happening over here, sucked into the asymptote. Y equals 0. Put in negative 1, and we get 3/2 to the first. Put in negative 2, 3/2 to the second, 9/4. Put in negative 3, 3/2 to the third, so times another 3/2, 27 on 8. Negative 4 times another 3/2, 81 on 4. Same values, just a backwards graph, and oh, doesn't that make sense? This negative is a pre-function multiplier. What was to the right goes to the left. So let's go. Negative 1 gets us to 3 halves. Negative 2, 9/4. Negative 3, 27/8. 8, 16, 24, 27. 8. Negative, oh wow, that should be 16 here, excuse me. Negative 4, a little bit more than 5. And again, you probably have room for a couple more values on there, but I promise you it is curving. It is concave up. Okay, so that should be a pretty darn quick page for you. And stay tuned, ask questions if you need to.